Welcome to the CLPS Firefly's Blue Ghost Mission What's on Board Media teleconference. I would like to inform all participants that your lines have been placed on a listen-only mode until the question and answer session of today's call. If at any time you wish to ask a question, you may do so by pressing *1 on your touch-tone phone. Please ensure that your phone is unmuted and record your name clearly when prompted. Should you need to withdraw your request, you may press *2. Today's call is being recorded. If you do have any objections, you may disconnect at this time. And I would now like to turn the call over to Wynn Scott. Thank you. You may begin.
Thank you. Good afternoon, and welcome to NASA's What's on Board briefing for the agency's Commercial Lunar Payload Services, or CLPS initiative. I'm Wynn Scott from NASA's Office of Communications. Today's briefing will cover the NASA science investigations and technology demonstrations on board Firefly's first flight to the moon. This briefing will address the significance of this CLPS flight and highlight the NASA-provided instruments flying aboard Firefly Aerospace's lunar lander named Blue Ghost. Our briefers today will be Joel Kearns, Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate at NASA headquarters, Ryan Watkins, Program Scientist in the Exploration Science Strategy and Integration Office at NASA headquarters, and Jason Kim, Chief Executive Officer of Firefly Aerospace. First, we'll start with some initial remarks from each of our briefers before opening it up for questions. We'll be taking questions on our phone, so if you've joined us today, please press *1 to add your name to the queue to ask a question. We'll now begin with opening comments from Joel Kearns. Joel?
Thank you, Wynn. We're all excited to be here today to talk about the next commercial lunar payload services launch and landing by a U.S. company which will conduct U.S. science on the moon's surface. This is one part of NASA's Moon to Mars road mapping, objectives, and architecture, and the U.S.'s Artemis campaign to explore the moon. Last Friday, NASA rolled out our update to the Moon to Mars architecture definition document, our top-level strategy, and today we're going to talk about one specific lunar mission coming up soon. Early next year, we'll continue to advance America's exploration of the moon. As part of Artemis, commercial robotic spacecraft will be used to conduct important scientific studies preceding and later in parallel with exploration by astronauts. NASA is contracting with American companies to take NASA's scientific experiments, engineering tests, and technology demonstrations from the Earth to the moon, land them on the moon, and then send our science data back to Earth. A reminder, NASA is very successful at robotic scientific missions in space using our standard practices. We often design spacecraft ourselves and test them, or have industry design them to our very detailed specifications under contract to NASA. That's not what we're doing here. We're exploring the surface of the moon robotically as part of Artemis, but using services from American companies instead of doing the missions ourselves within NASA. This is part of NASA's effort to use commercial services and public-private partnerships. For this work on the moon's surface, NASA's CLPS uses fixed-price service contracts, not traditional spacecraft development contracts. And the lunar missions are the company's missions, not a NASA mission. We're doing this to take advantage of the technical innovation and entrepreneurship that we see in American private industry to accomplish public goals. What we've asked industry to do, soft land and operate on the moon's surface, is not easy. It's extremely difficult, and we can't assure its success. In CLPS, the American companies use their own engineering and manufacturing processes instead of strict adherence to formal NASA procedures and NASA oversight to fly their own missions to the lunar surface that carry our equipment, cargo, and experiments. Today, you're going to hear about 10 NASA science and technology investigations to be conducted on Firefly Aerospace Blue Ghost Mission 1. This landing will be followed by more CLPS robotic commercial missions in 2025 and later years. Soon, NASA will also launch the Lunar Trailblazer water hunting satellite to orbit the moon. 2025 is definitely going to be an exciting year for lunar science. I'll turn it back to Wynn. Wynn?
Thank you, Joel. We will now hand it over to Ryan.
Thanks, Lynn. Thank you so much for having me here today. So I, alongside our project scientist, Maria Banks, have had the exciting opportunity to oversee the NASA instrument integration process for Firefly Aerospace's first mission, Blue Ghost Mission 1. So with 10 NASA instruments on this flight, we are looking at scientific investigations ranging from characterizing Earth's magnetosphere to understanding the structure, composition, and thermal properties of the moon's interior. We'll also be demonstrating technologies to help improve navigation and radiation-hardened computing technologies. Before I give a brief overview on the science that will be conducted on this first Firefly mission, let me tell you about our landing site. So the landing site for this mission is near a volcanic feature called Mons Lettre within Mare Crisium, a more than 300-mile wide basin that's located on the moon's near side. So this unique landing site will allow NASA payloads to gather critical data about the moon's regolith, the geophysical characteristics, and the interaction of solar wind and Earth's magnetic field. So this particular landing site was chosen because it avoids large magnetic anomalies on the lunar surface that could disrupt some of our payload measurements. It's also believed to have limited rocks in abundance, which will allow for safe operations with our onboard drill. In addition, this volcanic feature will serve as a good landmark for our terrain relative navigation capabilities on board the spacecraft. The NASA payloads on Firefly Blue Ghost Mission 1 will help advance lunar research and conduct several first-of-their-kind demonstrations, strengthening our understanding of the moon's environment, as well as helping prepare for human missions to the lunar surface. So this includes things such as testing the collection of regolith samples, testing global navigation satellite system abilities, again, testing radiation-tolerant computing, and the mitigation of lunar dust. The NASA payloads on this delivery represent the largest, in terms of quantity, manifest of NASA payloads on CLPS task order to date. These payloads come from all over the United States, including Montana, Texas, Maryland, California, 3 different NASA centers, as well as some significant contributions from the Italian Space Agency. So I don't have time to discuss all 10 payloads in detail, but let me give you a quick overview of some of the science that we'll be doing. So the moon's surface is quite the dusty area. As we design technologies and experiments for the lunar surface, regolith dust needs to be better understood and accounted for. Lunar dust can affect mechanical components, Earth-based materials, degradation, and human health, so we need to know how to account for its effects. So several payloads on board will help us study how lunar dust adheres to various materials, as well as test the usage of electromagnetism to mitigate or prevent dust buildup. We'll also be testing, again, radiation-hardened computing systems to help improve our computing technologies used in deep space. We'll be testing essentially the equivalent of GPS-type navigation. And then other scientific investigations on board will use X-ray imagery to study Earth's magnetosphere, which is where Earth's magnetic field interacts with solar wind. So we can use this data to inform decisions on Earth about things like weather predictions, protecting GPS and satellite connectivity, and other such things. So in short, NASA is using Blue Ghost Mission 1 as an opportunity to learn more about the internal structure of the moon, learn about Earth's magnetosphere, and test technologies that will aid in improving both robotic and human exploration missions to the lunar surface. And I'll hand it back over to you, Lynn.
Thanks, Ryan. We will now hand it over to our CLPS provider, Firefly Aerospace, and Jason Kim. Jason?
Thanks, Wynn, and thank you to Joel and Ryan for letting Firefly share the world stage. I'm proud to say we are in the final steps of sending Firefly's Blue Ghost lunar lander on its first mission to the moon. We call Ghost Riders in the Sky. On behalf of the entire Firefly team, we first want to thank NASA for entrusting us as one of their CLPS providers. The CLPS initiative has become the bedrock of commercial lunar innovation, and we look forward to continuing this partnership for years to come. I also want to thank our bold Fireflies for being relentless champions of innovating exploration across cislunar space. This Firefly team has gained a hard-earned reputation for smooth payload integrations, well-rehearsed operations, and robust testing throughout the Blue Ghost Mission 1 preparations. After a rigorous qualification campaign, Firefly's Blue Ghost lunar lander arrived at Cape Canaveral yesterday, and our team is currently working preparations for integration on SpaceX's Falcon 9 rocket. Following liftoff and separation, Firefly will lead a 60-day mission, including 45 days in transit to the moon and 14 days of surface operations after Blue Ghost lands on the moon. We'll be collecting critical payload science data throughout the entire mission. We'll then wrap up the mission by capturing a solar eclipse and a lunar sunset in high-definition video before operating several hours into the lunar night. We expect to capture a phenomenon seen and documented by Eugene Cerna during his final steps on Apollo 17, where he observed a horizon glow as the lunar dust levitated on the surface. Knowing that Firefly's Blue Ghost mission is a culmination of what the last Apollo astronaut to walk on the moon observed is a fitting tribute to their legacy. We're proud that our mission will support NASA's critical science and technology operations that will pave the way for a lasting lunar presence for our nation, our partners, and the world. While we recognize there will be challenges ahead, I'm confident Firefly's unstoppable team is prepared to softly land Blue Ghost on the moon and operate on this bold mission. Firefly stands ready. Let's go, Ghost Riders in the sky. Back to you, Wynn.
Thank you so much, Jason. Thank you to our briefers for those initial remarks. For awareness, we also have some additional NASA and Firefly subject matter experts on the line in case there are specific science investigation and technology demonstration questions that come up. We'll now open it up for questions. Again, for those on the phone, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, press *2 to withdraw it. Let's start with Gina Sinceri from ABC News.
I think this question is for you, Jason. What was the challenge, the size challenge, packing all of this onto Firefly Blue Ghost?
Blue Ghost is a very efficient lunar lander. It is capable of hosting a multitude of NASA science payloads to maximize the science value for the dollar. And it also has additional size, weight, and power allocated to commercial payloads if there are any commercial payloads that are available. So in this particular mission on Blue Ghost 1, we actually have 10 NASA payloads on there. And so that's the most of any CLIPS mission so far. So it was not a significant challenge to put all those on there. And we have a production line of these landers. And what's great about having a production line of these landers is that you learn from the first lander to the second lander and then some. And so anything we learn on Blue Ghost 1, I can assure you we're going to make sure that we use those lessons learned to improve Blue Ghost 2 and on.
Thank you. Our next question is from Marcia Dunn with Associated Press.
Yes, hello. I'm wondering if the cost of the mission is still at $93 million. Has that changed at all? And probably for Jason, there are 2 other lunar missions planned at the beginning of the year. And is there any conflict between those missions and yours, anything that needs to be worked out, any chances of getting too close and all that sort of thing? And it's been a tricky road to get landers to get successfully on the surface of the moon. And how worried are you about that? Thanks.
Firefly's NASA CLIPS task order for Blue Ghost Mission 1 is $101 million, up from the original $93 million. And that was really to accommodate a mission extension into the lunar night and other payload modifications. Again, just to reiterate, this is a fraction of the cost of the lunar missions from the Apollo program. As far as any conflicts that we foresee, what I've observed is that all the CLPS providers collaborate and have cordial relationships where we call each other, we talk to each other, we root for each other. And so when it comes to deconflicting things, I have high confidence with NASA and the other CLPS providers that we can resolve any conflicts and get ahead of it. So to answer your question, I don't foresee any conflicts in 2025.
I guess I meant not just from a mission point of view in terms of who gets there first or who's successful or not, but rather any kind of flight conflicts, any transit conflicts, any landing conflicts, that sort of thing.
I do not foresee any conflicts, and I would defer to NASA for their opinions.
Hey, Marcia, this is Joel Kearns at NASA headquarters. And you can imagine we look at all the different commercial missions that we are flying cargo on and investigations in CLPS, and we don't see any conflicts coming up with the launch date and landing date projections that we see. We look at things that folks have asked us about in the past, like, is there competition for deep space network comm? Is there any kind of competition, somebody trying to get the same launch window? We don't see any of that coming up for the year.
This is Ryan Watkins. I'll just add that the landing sites are also all different for these upcoming flights in the early part of next year. So no conflicts with the landing areas either.
Thank you. Our next question is from Jeff Faust with Space News.
Good afternoon. Question for Jason. Now that the lander is at the Cape, can you talk through what you're going to be doing between now and the launch in about a month's time to get the lander ready? And I'm also curious if you can confirm a report last week that you're going to be sharing the Falcon 9 launch with the iSpace Mission 2 lunar lander. Thanks.
Yeah, thanks, Jeff. I'll start with the second question. I would defer the answer to that to our launch provider, SpaceX. As far as the first question, I think the perfect person to answer that is Ray. She's our program manager on the Blue Ghost 1 mission. So over to you, Ray.
Yeah, thanks, Jason. My name's Ray Allensworth. I'm the spacecraft program director at Firefly Aerospace. And to answer your question about what we'll be doing over the next month with the Blue Ghost Mission 1 lander, like we mentioned, it arrived yesterday. We'll really spend the first few days doing inspections and functional checkouts for both the lander itself as well as all of our payloads. We'll do kind of some housekeeping, final wipe downs, final RBF removal, and then we'll move into propellant loading activity, which takes up a decent amount of the time that we have in the PPF. And then we'll go into kind of that final integration with our launch vehicle provider at about L-7.
Thank you. As a reminder for those on the phone, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, press *2 to withdraw it. Our next question will be Bill Harwood with CBS News.
Hi. This is for Jason, I think. Can you talk a little bit about the timeline? I mean, I was looking on the thing you have online about 25 days in Earth orbit, then 4 days to the moon, 16 days in lunar orbit, and then descent. Can you give us some sense of what you're doing in Earth orbit? In terms of what science you're doing there and phasing. And can you give us some detail on the descent to the moon? How you manage that? What sort of comms you have all the way down, and just the mechanics of the Blue Ghost lander. Thanks.
Yeah, sure. I'm going to probably double team this with Ray, but I'll start off before I pass on to her that once we launch, we're going to get signal acquisition within minutes. And then we're going to proceed through all the checkouts that we can do because we're traversing over 45 days to the moon. We're going to do electrical checkouts. We're going to do payload checkouts. That's one of the advantages of how we're going to transit to the moon is we can check out all the lunar lander and the payloads as well. We're going to do some orbit phasing around the Earth. We'll do some priming of the prop system. There's going to be some engine calibration as well. And then we'll commence with the first burn. The on-orbit payload science begins during that 25-day time frame. After that, we'll do the translunar injection. We'll do all the trim and trajectory correction maneuvers. And then finally, after 4 days of that, we'll do 16 days of the lunar orbit insertion. We have a vision navigation sensor. We're going to calibrate that. So those are all things that we're going to do on the way to the moon. And then on the descent, the thing that makes descent so hard, you've seen this with previous missions, is when you descend, you're constantly pulsing your RCS thrusters and your main engine. And what's so hard about that is the CG, the center of gravity, changes constantly. Meanwhile, you're also looking for hazardous surface objects and avoiding those. So we're doing all that, and we're going to softly land on the moon. That's the part that I'll hand it over to Ray to add in any more details. Over to you, Ray.
Yeah, thanks, Jason. Where you kind of left off as we go into that descent phase of the mission, we'll come around the far side of the moon after being out of a comms blackout, and then we will begin descent, which is actually the only autonomous portion of our in-orbit operations. So at a certain point in time, the lander will go into an autonomous state through descent to then softly land on the lunar surface. That's when our Firefly mission operators will go back hands-on and begin safety checkouts of the lander, confirm its location, orientation, confirm its functioning as planned, and then we'll immediately step into the rest of those payload operations on the lunar surface.
Hi, this is Ryan Watkins from NASA. I can also, from the NASA side, speak to some of our instruments that will be operating during transit and landing. So we actually have one set of cameras on board called the stereo camera for lunar plume surface studies, or SCOUTS. So they'll be using stereo imaging to capture the effects of rocket exhaust on the regolith as the lander descends onto the lunar surface. So these images that they'll send back are going to aid in creating models to predict lunar regolith erosion, which is going to be really important, especially as we start to send bigger, heavier, payloads, landers, and ultimately crew to the moon. We also have a couple of payloads that will be operating during transit on the way to the moon. LuGray, which is our lunar GNSS receiver experiment, will be demonstrating a possibility to acquire and track signals from global navigation satellite systems, specifically GPS and Galileo. So they'll be doing this during transit to the moon, during lunar orbit, and again on the surface. And then again, I mentioned a few times earlier our radiation-tolerant computer experiment will also be operating during transit, going through the Van Allen belts, and looking at how the computer's ability to withstand space radiation kind of holds up as it passes through those radiation belts.
Thank you all. Our next question is from Vincent Martirano with CBS Austin.
Yeah, hi guys. I think this question might be for Jason here, but you guys talk about what's going on the lunar lander and what you guys are going to be doing, from the phases in Earth's orbit up to the moon. But I guess the question is, what is the significance behind the research? What are you guys looking to accomplish from your guys' mission up to the moon?
Well, I'll start by saying this is historic because, as a nation, we haven't successfully stuck a landing on the moon in over 52 years. What's even more significantly important is that this will be the first time a private company successfully sticks the landing, does a soft landing on the moon as well. So it just shows that the private industry, the commercial world, has a lot of affordable, responsive technology and systems that could provide NASA a frequent means to go to the moon and carry out all these high-stakes critical science missions for lower cost, as well as do it sustainably. We believe in a future of a very robust lunar economy. It is the gateway to other planets like Mars. And so just enabling the frequency of very affordable and high science value missions is what private industry is doing with this first Blue Ghost 1 mission.
Hi, this is Ryan Watkins from NASA again. Just to speak a little bit more to the significance of the science that we'll be doing. So again, we've got a nice variety of payloads on board that will be understanding the lunar regolith, the geophysical characteristics. We're going to be measuring heat flow from the interior of the moon in order to better understand the interior structure. We've got payloads that will be looking at, again, the structure of the moon's mantle by measuring electric and magnetic fields. We've got, again, a couple of technology demonstrations that will help, support operations both on this mission and future missions, looking at mitigating dust buildup on different materials, as well as a payload that will be looking at the Earth's magnetic field and how it interacts with solar winds. And that's just kind of a really broad overview. Again, we've got 10 different payloads all conducting really interesting investigations in science to help us better understand the structure of the moon.
This is Joel Kearns from NASA. I'd like to add to Ryan that, science enables exploration and exploration enables science. We say that at NASA when we look at Moon to Mars. We get recommendations from the National Academy of Sciences for what our scientific goals are and what our major scientific questions are that the nation should pursue in space through a series of reports called decadal surveys. And NASA used those decadal surveys to help build our Moon to Mars objectives, which are available publicly. The individual investigations we fly, particularly the scientific investigations, tie right back to those Moon to Mars objectives for science, and the technology development and the engineering demonstrations that we do tie back to the other objectives that are part of the Moon to Mars objectives. So no individual experiment on a 14-day mission will be able to totally answer a scientific question from a decadal survey or totally answer a Moon to Mars objective, but these 10 investigations make progress on the way to accomplishing those objectives.
Thank you all. Our next question is from Will Robinson with Spaceflight Now.
Hi there. Thanks so much for taking the time to speak with us today. Believe my question is to Ryan Watkins, although Jason, since you brought it up, if you can chime in, that'd be great as well. In an earlier comment about the cost of the mission, it was mentioned that it was changed in part due to other payload modifications. I wonder if you could expound upon what changed specifically from the original vision of this mission to what it is right now. And then a quick question to Ryan as well. The payload called Planet Vac that will be suctioning up a sample of lunar regolith, following the analysis, what happens with that? Is that going to be preserved for potential future collection years down the road, or just deposited back on the lunar surface? Thanks.
Yeah, great questions. This is Ryan Watkins. So for your second question, are you asking what is going to happen with the samples they're collecting, or just with the data behind the experiment? Just so I make sure I understand the question.
With the physical samples themselves.
Yeah, so this particular mission, there's no samples that will be returned. So I will answer part of your question and then perhaps hand it over to our project scientist, Maria Banks, to maybe give some more details. So Lunar Planet Vac will be collecting regolith samples from the lunar surface or using a burst of compressed gas to kind of drive the regolith into a sample chamber. So they'll be collecting and analyzing that data and then transmitting the results back to Earth, and that data will be archived for for future investigators. As far as kind of what they're doing beyond that, I'll let Maria, if she's on, handle the rest of maybe some more details on that question.
Hi, this is Maria Banks. So what Ryan says is absolutely correct. And yes, there's no sample return. So the samples, it's really just testing the technology to see if it can actually use this technology to successfully take a sample of our very fine lunar regolith and other size particles in the regolith as well. And so the data will be captured with images that will be archived. And so that will be available to the public to learn more about the success of that technology and to actually see what samples were acquired and what that looks like. And they'll be able to get some science out of that as well. But otherwise, the samples will just stay there on the surface in the instrument. There's no plan to collect them at any point at this point.
And this is Joel Kearns from NASA. I want to address the first question you posed about the contract value for the landing. As Jason pointed out, relatively early, but after we awarded the contract, NASA exercised options that we had put in the contract to gather images of the lunar surface and also to do these limb horizon observations for NASA to get all images of the horizon on a 360-degree coverage. This was something that we had asked people to bid on for this, but we didn't exercise that as part of the contract when we immediately issued it. There were also instances where the interfaces changed or as payload development matured, and we decided to update the interfaces on the Firefly side. So we asked them to make some changes so that we could mature the interfaces further on some of the NASA-provided payloads, the 10 payloads. Firefly also started this work. They competed for this in 2020, and they won it in 2021 while the world was still exiting COVID, and also we were learning to understand some of the supply chain issues related to the payloads and other complex systems. So there were a variety of relatively small changes that over several years increased the contract value from its original award value to the current value that it has.
I would also add to what Joel said is that in the contract value, we purchased the launch vehicle service as well.
Thank you all. Our next question is from Marcia Smith with Space Policy Online.
Thanks so much. This is Marcia Smith with SpacePolicyOnline.com. And I just wanted to clarify with Jason that the NASA payloads are the only payloads on this. There are no other customers that you have. And secondly, I'm curious as to whether or not you've learned any lessons from the flights by Astrobotic and Intuitive Machines, either in terms of the design of your lander or in the operations of it between here and the moon and during landing. Have there been any lessons learned that they've shared with you?
First of all, the majority of our payload capacity on Blue Ghost Mission 1 is allocated towards our 10 NASA-sponsored payloads, which is, again, just to reinforce, that's the most that's been carried to the moon to date under the CLIPS program. We are flying some very small payloads from LifeShip that encompasses a memory card of Moon, Mars artwork. And so that answers that question. As far as learning from other companies, that's something that I was advised to do, and I thought that was a great idea. So I've spoken to each of the other CLIPS providers that have gone to orbit and talked to their CEOs, and it's been a great conversation. We expect to continue those conversations. I think both prior CLIPS missions, the CEOs were very transparent, and so you could look at a lot of documentation on how each of those programs went. So there's some systematic learning, systematic process learning. There's also hardware learning and software learning. And so those are all the things that we work together to share notes on, and we'll do the same with Blue Ghost 1 in the essence of ensuring that the CLIPS program is successful.
Thank you. Our next question is from Irene Klotz with Aviation Week.
Thank you. I have two questions for Jason. Hi. Could you just discuss a little bit about any constraints on your launch opportunities? Can you go every day? Do you have a specific time of day when you can launch? And what currently is your no earlier than date? And for Joel, could you recap where NASA stands on all the CLIPS task orders and separating out the Mastin, which I believe was officially canceled, and the Orbit Beyond? So just to give us a sense of where you are in the program. Thank you.
Yeah, just to start with the first question, Blue Ghost will launch on a SpaceX Falcon 9 rocket, and it's going to be a 6-day window that opens no earlier than mid-January 2025.
And this is Joel Kearns from NASA. We're pursuing with industry all the task orders that we've awarded, with the exception of the two you mentioned. You know that Mastin went into Chapter 11 reorganization and was eventually sold off. And one of the original three CLIPS task orders, as you mentioned, the company withdrew relatively early from pursuing that task order delivery. We have two other task orders with Firefly to come in the future. One is called CS3, they'll land on the far side, and one is a complement to that called CS4 to do an in-orbit calibration beacon for the instruments that'll be on that far side landing. I would say, for more detailed information, I would say go to the NASA website, but the task orders, we have several other task orders where the companies are working to fly them in 2025 after the Blue Ghost Mission 1, and you'll hear about those as the companies get closer to launch, and we have follow-up what's on board telecons like this one.
Thank you all. Our next question is from Manuel Mazzanti with Exploración Especial.
Thank you so much. How are you? This is for Joel or Ryan, probably. I would like to understand, how is the process for selecting a landing site? Was Mare Crisium a NASA target for a while because of its volcanic features? How is the process working with the commercial partners? Do they get involved at some point? Is it a joint decision, or is it basically a NASA decision? And Jason, could you please repeat when the launch window opens again, please? Thanks.
Yeah, this is Ryan Watkins from NASA. So interesting question about landing site selection. So the process has actually evolved a bit as the CLIPS program has evolved. For our first few CLIPS deliveries, it was kind of up to the vendor to choose a landing site based on where they could safely land. Now, as we're kind of building up our scientific payloads, often the landing site is driven by the science that we need to do. And again, that varies delivery to delivery. For this particular delivery, yes, Mare Crisium has been a high priority target for a variety of reasons. It's a large impact basin. Lots of good data that can be obtained there to understand basin chronology. There is, different volcanic features that we'd like to study to help us understand the volcanic history of the moon and how it formed and evolved. So landing near this volcanic feature within Mare Crisium, again, this particular area was chosen in part due to avoiding magnetic anomalies on the lunar surface that could interfere with some of the observations we need to take of the Earth's magnetosphere. We also needed to look for things like rock abundance, because again, we have a drill on board. Obviously, also want to land on a surface that's got a lot of rocks. It's not safe for a variety of reasons. So there's again a lot of good reasons there. So we usually go back and forth with the payload teams to make sure that they can achieve their science at the different areas that we're looking at. It tends to be iterative. But yeah, it's ultimately chosen by NASA and then worked with the vendor.
And this is Joel Kearns from NASA. I'll point out for the competition we ran recently for scientific instruments to go on CLPS landers, we had the U.S. proposer propose the landing site. So sometimes we, in order to optimize the science of the investigation, we will have the scientist who's making the proposal to NASA, who's competing to be selected, propose the landing site on the moon, particularly if it's not at the South Pole, because we have many investigations and many engineering developments that want to go to the South Pole of the moon. But if it's a place other than the South Pole, we'll have the U.S. scientists propose it, which means there could be a large number of different potential landing sites that will go on the moon. And once we make a selection of that scientist and their instruments, that will set the landing site for that CLPS mission.
And just to repeat the answer on the question of when we're launching, the Blue Ghost launch on the SpaceX Falcon 9 will be within a 6-day window that opens no earlier than mid-January 2025.
Thank you. Our next question will be from Robert Perlman with Collect Space.
Hi, thank you. I think this question is for Jason. We've heard about the active payloads that NASA's putting on, but did Firefly put any of its own commemorative payloads on board? Do you have a plaque, or did the employees sign the spacecraft somewhere? Any particular markings on the lander? And with regards to the name of the mission, could you license the song from Johnny Cash?
Yeah, so those are great questions. The first question, to answer that, we most certainly did take the opportunity to put the names of our Firefly employees as well as investors. So that's something that we're very proud of, to have your name associated with a vehicle that's going to land on the moon and stay there is quite inspirational. So that's something that we're looking forward to. Blue Ghost and the Ghost Riders in the Sky name, I'll just go back to just rewind a little bit. Why do we call it Blue Ghost? It's named after a firefly species found in the southeast region of the United States. For fireflies that have this distinctive blue glow. And then our mission name, kind of going along the same theme, Ghost Riders in the Sky, further plays into that Blue Ghost theme. And, being one of the first commercial landers on the moon, Blue Ghost is essentially forging a highway to the lunar surface. And that's going to enable regular access for both commercial and government customers. And so it really plays well with, Ghost Riders in the Sky. It's a nod to the team and to this long trip. And so that's why we named it that way.
Thank you. Our next question is from Alexandra White with Nature magazine.
Hi, thanks for taking my question. My question is for Ryan. You talked about some of the payloads that would take data while in orbit, in transit, essentially, on the way to the moon. But can you talk a little bit more detail about kind of which ones will get their science objectives done soonest? I guess I'm just kind of wondering, if the mission doesn't play out as planned and terminates earlier than expected, like which of the payloads are going to get most of their science done earliest in the course of the mission?
Yeah, good question. This is Ryan. I'm actually going to hand this one to our project scientist, Maria Banks, who's been working with our payload teams on their concept of operations and who's getting data when. So she's probably well pleased to answer this.
Hi, this is Maria Banks. Yes, so we have, as Ryan was mentioning earlier, we have a couple payloads that are actually operating while we're in transit to the moon. So they would be, if we, on the way to the moon, they'll already be getting science. So that's RAD-PC, that's our radiation tolerant computer, and LUGRA, which is the one that's looking at the GNSS signals all the way from Earth at different time periods in transit on the way to the moon, and then at the moon and on the surface there too. So those are the main ones that are operating in transit. Then the Scalps cameras they get to shine as we're descending down to the surface. As Ryan was mentioning, they're capturing images in stereo, so they're going to look at that plume surface interaction. So, and then they're going to operate very quickly right away on the surface too, to also take images as literally the dust settles. And then basically those first 24 hours on the surface are very, very busy, and just about all of our payloads are operating at that time. The only ones that aren't are maybe they have a few like thermal issues that need to, I won't say issues, that's the wrong word to say, thermal conditions that they need to keep an eye on before they can operate. Our Lexi instrument, which is going to be looking at the magnetopods, they need to get into operational temperatures, so they need to warm up. So they may not be able to operate for the first 24 hours, but we'll keep an eye on that and get them operational as soon as we can. Same thing with the Lister drill. They have to also wait until the conditions are right for them to go ahead and operate. But all the other instruments will be powering on within those first hours on the surface. I'm sorry if you hear dings in the background here. Yeah, the rest of them will be operating, so we should be hopefully getting data pretty quickly. It's very busy on that first day on the surface.
Thank you. Our next question is from Leonard David with Inside Outer Space.
Yeah, hi. Can you hear me okay?
Yes.
Okay, great. Maybe for Josh, I was a little late getting on board here. I hope you didn't cover this, but I'm very interested in the control centers now at your group and how they were shaped and what kind of capability do you have? How many people will be staffing that? Any insight on how that all came together for you guys?
Joel, I think that was a question for me. This is Jason. Mm-hmm. I think the perfect person to answer this is Ray, our program manager on Blue Ghost 1. She will be in the control center during the full operation. So over to you, Ray.
Thanks, Jason. Yeah, so our Mission Operations Center is centered really close to our Firefly Aerospace headquarters just outside of Austin, Texas. And it's a facility that we've developed and ultimately became operational within the last 8 to 10 months. And this is the Operations Center that will be working on the lander all the way from launch through our surface operations. And it will have be various levels of staff, but we'll have effectively 24-hour coverage throughout our entire operation over those 60 days from launch through descent and then surface operations. And I think one of the things that's really special about this Mission Operations Center are the operators that will be in there. They're largely engineers that have worked on the program for many months, if not many years. They were also the individuals that have designed, built, and tested our lunar lander. So they're extremely experienced operators. They're very familiar with the lander. And they're also very familiar with the NASA payloads that are on board, since they've also been working with those payloads and the NASA team over the last 3-4 years, getting us ready to launch and land.
Thank you. We have time for a couple more questions. Our next question is from Josh Dinner with Space.com.
Hi, Josh Dinner with Space.com. I think my question is for Jason. Once the end of mission arrives, about how many hours into the lunar night is the lander going to remain operable?
It's going to be operable for another 5 hours. And so we're going to test the limits of operating within the lunar night.
Thank you. Our last question will come from Bill Harwood with CBS News.
Hey, thanks very much. Just a couple of quick ones. One for Joel. Is there a cost associated with the NASA-sponsored instruments, or is that folded into the overall contract value you talked about earlier? And for Ray, I was looking for a bit more detail on the landing sequence. I was wondering, what is the altitude of the low lunar orbit that you're going to drop down from? And could you just talk a little bit about the engine firing sequence and how you get down to the surface? And finally, when can we expect to see pictures from the surface? Could we get that within hours? Is it going to be days? I'm just curious if we have any idea when we'll see those first images. Thanks.
Hey, Bill, this is Joel Kearns. The cost of the 10 NASA payloads is $44 million, and that's in addition to the task order costs that Jason and I talked about earlier. And there's the one cost we don't have, which isn't part of the $44 million, is the Italian Space Agency provided some of the hardware and the software for the Lugray payloads. That was an outside of U.S. expenditure, and I don't have a number for that expenditure.
I can take the second half of that question. You asked about photos and when we should expect them upon landing. We've hoped to have our first image within about 30 minutes of a nominal landing using our S-band antennas. However, the timing is largely dependent on our data availability, which varies depending on which position, basically the position of the spacecraft after landing and the position of our ground stations on Earth. Within a couple hours of landing, we'll also deploy and calibrate our X-band antenna, which will then allow us to downlink HD, so high-definition imagery and video at a much faster data rate. You also asked a little bit about our kind of descent ConOps. So the lander, once it's in lunar orbit, it will effectively do some phasing orbits to get to a lower lunar orbit. And it's a trajectory that's been really specifically designed for us and this mission. So we'll get to that low lunar orbit before ultimately going into our descent phase, which is where, as I mentioned earlier, we will effectively be autonomous, and the lander will operate on its flight software and vision navigation software to get us safely to the lunar surface.
Thank you to everyone who submitted questions, and thanks to today's briefers for taking the time to discuss NASA's CLIPS initiative and Firefly's upcoming mission, Blue Ghost Mission 1. As a reminder, Firefly is scheduled to launch aboard a SpaceX Falcon 9 rocket no earlier than mid-January. Thanks again for joining us. That will wrap up today's briefing.